Eu sou Ronaldo Lemos e esse é o Expresso Futuro. Hoje a gente vai falar exatamente do futuro da saúde.
We have a lot of questions to ask ourselves about engineering human embryos. Whether or not we do it is going to be less a question of capability and more a question of ethics.
Are we going to have the wealthy people engineer all the faults out of their line, whereas all the poor people are going to have those diseases?
Ultimately, the future of healthcare is not brick and mortar. It's not in the clinic. It's out in the real world. It's on the phones that we have in our pocket, the devices in our home, and that's ultimately where we're headed.
In the not-too-distant future, our DNA will determine everything about us. A minute drop of blood determines where you can work, who you should marry, what you're capable of achieving.
Com tantos avanços tecnológicos, a saúde não poderia ficar de fora, né? Tem muita coisa acontecendo nessa área. Uso de dados para prevenção de doenças, a pesquisa em biotecnologia que está cada vez mais acessível, saindo dos laboratórios e criando um movimento de faça você mesmo e muito mais. Para o Brasil, isso é muito importante, porque nessa área a gente tem tantos déficits e tantos problemas que eu acho que tem muitas oportunidades que o avanço tecnológico pode trazer. A gente vai falar agora com a Ellen Jorgensen. Ela é uma grande ativista do movimento Faça Você Mesmo na área da genética e luta também por maior liberdade para o uso de tecnologias patenteadas, que muitas vezes as patentes podem dificultar ou até mesmo impedir a pesquisa nessa área.
The definition that we use here at Biotech Without Borders is biotechnology being done in an unconventional space by unconventional people. There's a lot you can do by analyzing the DNA of yourself, of your food, of the environment you're in. Some of it is actually, I think, very empowering for communities and consumers. For example, if you could have on-the-ground sites that were capable of manufacturing a vaccine in a lab that wasn't terribly sophisticated, but had the basic molecular biology tools. The ability to very quickly create different vaccine alternatives and test them. To have that sort of thing as a more distributed endeavor would be the next step in a way, rather than having it centralized. I'll give you an example. I have a friend who's diabetic who's told me that the people that wear insulin pumps are banding together and hacking them because there's certain functionality in them that they want them to have, and the company has said it's too expensive to add it, and they did it, and now the company is embarrassed. Wait a minute, you said it's too hard, too expensive. Look, we did it. So I think if the company is a good company, they'll see it as an opportunity to partner with the public because the public are their end consumers. If the company is a bad company, they may try to shut it down in some way, but it's very hard to squash innovation. I think the thing that people are most interested in is it has a couple of very controversial applications. For the first time, we may be truly able to edit a human embryo. Closer and closer we're getting to that whole science fiction scenario where you can actually do genetic engineering on humans. This is not a simple thing because of course it opens the door to doing other types of edits, and where do you stop? What's considered a defect rather than just something that somebody wants, you know? That's why I like to teach these classes, is because, yeah, there's a fun hands-on component, but you also get into all of these discussions about, well, what does it mean? How should this be used? Obviously, the only way you can edit an embryo is if someone is doing in vitro fertilization. That's a very expensive procedure. You have to be fairly wealthy to afford it. Are we going to have the wealthy people engineer all the faults out of their line, whereas all the poor people are going to have those diseases? I mean, there's also kind of social questions that this kind of tech raises. These spaces are more than just places to play with biology and have fun. They're places to think about what this means. What does it mean that it's easy now for you to go and analyze your own DNA? These were Nobel Prize winning experiments maybe 20 years ago, and now you're doing them in a crappy little lab in the middle of an industrial building in Brooklyn. So this is the future.
Genetics, what can it mean? The ability to perfect the physical and mental characteristics of every unborn child.
Of genetic engineering to choose the genes.
A pesquisa em biotecnologia, ela está saindo cada vez mais das universidades e dos laboratórios tradicionais e indo para lugares comunitários. A gente vai visitar agora o GenSpace, um laboratório de experimentação genética comunitário que fica no Brooklyn, em Nova York. É interessante porque lá eles estão fazendo vários experimentos com a tecnologia genética CRISPR, que permite, inclusive, a edição genética de pessoas vivas, ou plantas, ou animais, e assim por diante. É como se fosse um hackerspace, só que em vez de computadores, você vai encontrar material de pesquisa biotecnológica. Vamos lá ver.
GenSpace is something that we call a community lab. The idea is a molecular biology laboratory that is open to the public. Biology, it's actually coming a little bit back to its roots. A lot of scientists in the past, or people who we call scientists today, weren't actually professionally scientists. They were just interested in certain aspects of nature and wanted to learn more about it. It really wasn't until the 20th century that this idea that you would be paid a salary to put on a white coat and walk into a lab and do science for 40 hours a week really became the convention. And so I think we're sort of seeing this make a resurgence now in biotechnology. And so if you have a place like GenSpace or some of the other community labs out there that have already acquired the equipment, it becomes possible for citizens to make contributions to biotechnology again. So one of the big draws to me, say my company had given me permission to work on a side project there. Anything I discovered would have belonged to the company. I wouldn't have had any say in how it was used. I really wouldn't have had, any ownership of the idea or the product or whatever it was that I created. One of the nice things about GenSpace is if you discover something here, if you invent something, it belongs entirely to you and you can decide what to do with it. So we've seen startups launch out of here that are built around intellectual property that they developed here and have complete ownership of.
O que está acontecendo hoje é que os equipamentos para isso estão ficando cada vez mais baratos. Hoje é possível comprar um kit de manipulação genética pela internet a menos de $100. Isso está provocando uma verdadeira revolução. É parecido com o que aconteceu com os computadores na década de 70. Antes, computador era coisa de empresa. E graças a um monte de pessoas, como por exemplo Steve Jobs e outros hackers, eles começaram a levar o computador para suas garagens, o que iniciou o fenômeno do computador pessoal. Hoje, a gente está vendo a mesma coisa acontecer em biotecnologia. Há uma verdadeira onda do faça você mesmo, com as pessoas fazendo experimentações fora de laboratórios, e há quem aposte que isso vai fazer a pesquisa em genética avançar ainda mais e mais rápido.
Biotechnology today is sort of where computers were back in the 60s. We have the transistor, we can do a lot of basic operations with it, but At the end of the day, right now, writing a genetic program is a bit like back when you had to manually punch cards for early computers. And I think as automation becomes more prevalent, we're going to hit a point where next to your inkjet printer, you have a DNA printer. And the act of just writing a program for DNA and exporting it into, say, yeast or E. coli or even a tomato is going to become very trivial, and it's going to be a thing where instead of having to walk into a lab like that and do everything manually, there's going to be a device that you can buy that's just a little lab in a box that does all that work for you. Personalized medicine is going to begin to really emerge as a field in the next couple of decades. And I think it's going to be an interesting sort of merging of biotechnology and AI, actually.
A gente vai visitar um dos laboratórios que fazem parte de um dos hospitais mais importantes de Nova York, o Lab 100. É muito interessante porque os hospitais aqui da cidade já são muito tecnológicos. Você consegue marcar uma consulta pela internet no mesmo dia e, mais do que isso, muitas vezes você consegue fazer a consulta pela rede, falar com o médico direto do hospital sem precisar sair de casa. Agora, esse laboratório, ele está fazendo algo além. Ele está usando dados para fazer um planejamento da sua saúde e para fazer prevenção de doenças. Vamos lá falar com eles.
Welcome to Lab 100.
Thank you.
Lab 100 is a hybrid clinic and research lab where we're leveraging data and technology to redesign how we measure health and ultimately redesign how we deliver care. And each station is going to measure another aspect of your health, and we're going to talk about the results as we go, definitely interject with questions. The point of this is to be informative and educational to you, and we're trying to really empower our patients to understand how their behavior and lifestyle impacts their health in a very tangible and quantitative way. Nice, how about that?
That's good.
All right, we'll save that. Everything we do in Lab 100 has immediate clinical utility and research utility. So we have your vital signs collected, and now we're gonna check out our initial consultation. So let's bring up some of your data. So you're pretty physically active, it looks like. You're getting a high level of physical activity, and it looks like the vast majority is from vigorous activity, 91%. That's wonderful. Nice. In terms of your nutrition, you're getting significantly above average vegetables. Your blood pressure is excellent within the normal range. Your heart rate, 63 beats per minute.
Very good.
Should we move on?
Yes.
All right,
good.
Let's go to the blood draw.
Good. Where did you come to the realization that it's important to merge research and actual physical exams?
What became very apparent to us several years ago was that we've sort of reached the limit of what we could do with the traditional healthcare data. I always make the analogy that it's sort of like everyone is building mechanical horses to pull a carriage, because we have this old, way of practicing medicine that really hasn't changed, that much over the last 100 years. We have this new technology like AI, big data, et cetera. We're trying to make it work in this old way of doing things. So what we quickly realized is we needed to be able to control or change the data generation side.
We're trying to get the right data together in one place where we can ask the right questions of that data. And today, we're stymied by the fact that we largely don't collect data about health. We collect data about acute episodes of disease when patients come into the hospital or the clinic. So the more we can start collecting truly health data and more holistic data from molecules up through behavior and population level data, that's how we're going to move innovation forward.
That's amazing. Also providing access to the patients, right, to their data, because I think this is also a revolution. There has been a dispute that's been going on forever about who gets to see the patient data and so on.
We're moving very rapidly in that direction. Here in Lab 100, the patient is the owner of their data. When you come through a Lab 100 visit, we try and make every piece of data that we collect immediately visible and also contextualized for the patient to understand. After you leave Lab 100, that data is yours. You can download it, you can share it, you can email it. If you're a data scientist like us, you can even work with it on your own.
Sure.
And we really want to empower our patients to understand their health. We know the innovation that's unleashed when you open source what you're doing.
That's right.
When you make tools that allow others to build on the work that you're doing. So we're doing a lot of that here as well. The purpose of the final consultation is to review all the data we collected and see whether we can come up with any key areas to focus on. So we show your physical activity and nutrition again up here to remind you that these are the levers that we have to adjust. This is really what you can do in terms of behavior and lifestyle to impact your health. Lab 100 is the means, it's not the end. We built Lab 100 with a very specific purpose in mind, and that was to dramatically shorten the time it takes to innovate in healthcare. We know that today it takes 17 years on average for new biomedical innovations to see the light of day. A lot of that innovation never even gets to the end user, in this case to the patient or to the provider who would stand to benefit. And one of the reasons we think that's the case is because the key stakeholders, the people involved in innovation, right now they're siloed across various aspects of the healthcare system. With Lab 100, we're bringing everyone together in the same environment, and that's enabling us to learn from the feedback we get from our patients, from our providers. And once we get that feedback, we can then develop different versions. Ultimately, the future of healthcare is not brick and mortar. It's not in the clinic. It's out in the real world. It's on the phones that we have in our pocket, the devices in our home, and that's ultimately where we're headed.
O futuro da saúde hoje depende de dados. E quanto mais personalizados esses dados forem, melhor. Tem uma empresa aqui em Nova York chamada Next Gen Jane, e eles criaram um dispositivo para analisar os dados do sangue menstrual. É um absorvente que você utiliza e a partir dali a mulher pode coletar dados sobre a sua saúde, questões reprodutivas e assim por diante. É uma excelente ideia para a gente poder avançar a área de saúde da mulher usando também a tecnologia.
You know, I was trying to find ways that women could track their reproductive health. And currently in our medical system in the United States, you use many different things. You do take a venous blood sample, you do go into a gynecologist and you get up on the table and you sit in stirrups and they use a speculum to open you up. It's a process that many women are familiar with and many women dread. It's something that I want to make easy for women. You want to incentivize women and encourage them to get involved in their reproductive health. And so I was really trying to think of ways I could access blood. I could access the same cells that you do when you try to get a pap smear. How's an easy way to get cells from your reproductive system? That's how we thought about menstrual blood. We want the woman to do exactly what she would do on her normal monthly period because we want to integrate into a regimen that she already has and not disturb it. And she uses a tampon that we send to her. She uses it, she takes it out of her body when she's done, and she puts it into our device. And what the device does automatically is it takes a particular preservative, it's a buffer, and it runs it over the tampon. And it actually extracts the material that we need from the tampon. So we actually look at the genomic signals from the cells that you're shedding during your monthly period, and we're trying to figure out what's happening in your body depending on what genomic signals that we're reading. One of the big trends I noticed about tech and what it's doing is it's obviously empowering the consumer. People like being in charge of their health. Not like this 1950s version where you imagine you see the same doctor for your entire life. They deliver you, they deliver your children, they deliver your grandchildren. And this doctor knows everything about you. No one owns your health. There's no one doctor that's managing you for more than probably, what, 18 months? And so where does that responsibility fall now? It falls to you. That fundamentally breaks that paradigm of centralizing the doctor in one place, if you can do the sample collection at home. So that's really important, because when you lower the activation energy for actually taking care of yourself, you're more likely to do it. One of the things that's so important about this decentralization trend is you actually make it so easy to engage with your healthcare that you can do it naturally and easy. And we've always found in our clinical trials, women are more than happy to contribute to efforts like this. We want to encourage you and inspire you and motivate you to say, please use it for science, use it to investigate other diseases that women can find out about themselves.
Não só de ciência vive a biotecnologia, existe também a bioarte, que é usar esse tipo de técnica genética para criar um objeto artístico, um objeto estético, usando para isso, inclusive, seres vivos. A gente vai entrevistar agora duas pesquisadoras do laboratório de bioarte da Escola de Artes Visuais aqui de Nova York.
In this current environment, particularly in the 21st century, we all live under the umbrella of altering nature. And artists have always been involved with nature, and goes all the way back to the early cave paintings. Painters at that time used pigments to create images of the natural world. So each generation kind of redefines the relationship to nature in art, and now the umbrella for us is really the genetic revolution. Artists are really those that thrive on freedom. They are not afraid to do things scientists would never dream of. But it's not a complete kind of switch. There is subjectivity in science, although scientists would like to say there isn't. And there is objectivity in art, although some artists may say there isn't.
I started off as an artist from the very beginning. I've always been very attracted to materials. And as an artist, I began dabbling in new territories, many of which weren't my own. So I began dabbling in the sciences and eventually became a part of the BioArt Lab movement. Our art students have come up with very innovative ways to apply some pretty standard lab reagents. And this one is a bacterial cellulose, so you can see it's growing on the surface of this culture. So as an example of a way in which an artist would harness this organism, we took advantage of the fact that the SCOBY, the cellulose, grows on the surface, and we 3D printed scaffolding. And the scaffolding protruded the surface of the liquid, and the cellulose had no choice but to grow around those obtrusions, which was allowed us to create our own pattern in vitro. So this is an extension of my interest in the bodily fluids that sustain us. I'm particularly interested in the relationship of photosynthesis and respiration as a means of bonding the survival of flesh and flora. And again, I'm an artist. I don't have a background in molecular biology, but was really compelled by the molecular structure of the two molecules responsible. If you look at hemoglobin and chlorophyll, they're practically identical except for their center atoms, which is really unusual for molecules. What you see here are spinach leaves in an ethanol solution. And the ethanol is a strong alcohol, and it leaches out all of the chlorophyll. So all of the green pigment that captures the sun's light and converts it into energy is suspended in the liquid, and the leaves are kind of bleached and fleshy. So the chlorophyll solution is dripping down into the beaker, and you'll see that while it appears green here, it's red below. Literally glows red like blood, which is so bizarre. If I had to sum up my relationship to science, it would be poetic. And my understanding of simply poetic. And it's also a freedom, it's a disclaimer. So as artists, one of the things that we're great at doing is taking the abstract and making it tangible, making it compelling and something that's visceral. We're bombarded with information about the world around us, and the information, the numbers, are just as abstract as the invisible liquid in a test tube that, a scientist is pipetting into another test tube. And so I think it's a really great opportunity for artists to build a bridge between some of these abstract notions for the public. These are things that are going to affect design our future. It's important that we begin to feel that reality before it creeps up on us. And artists have a lot of potential to set a stage, not only for us to confront some of these things that are looming, but also a place for us to hold and face these issues.
More and more biological solutions to the changing dynamics of the degradation of toxicity, the ways in which GMOs exist, the use of plastics, etc. These are all issues that artists are dealing with. And it's to raise a certain consciousness about we all live in the same world. And what happens in one place now affects us in another.
Como tudo mais, a biotecnologia traz também preocupações. É preciso que a gente sempre se lembre da dimensão ética desse tipo de prática. Se a gente for pensar, a biotecnologia traz muitas promessas importantes. Reduzir a fome, até mesmo expandir o tempo de vida nossos seres humanos. A questão é sempre importante fazer isso com responsabilidade e tendo um compromisso de que a gente vai sempre usar essa tecnologia que se barateia de forma ética. Se a gente fizer isso, tenho certeza que os benefícios vão ser muito maiores do que eventuais malefícios.